This is the start of a new section. This is section 5.4. We're going to be talking about exponential functions in this section. We're going to go ahead and talk about derivatives and integrals in the same section this time. So first, we need to do a little bit of pre-calculus review, just like we did with ln. So that's what today is going to be about. Exponential functions are the opposite of logarithm functions. So an exponential function is when a base, let's underline that, is a constant, and the exponent is the one that's a variable. So it's kind of backwards from what we usually talk about. So such as y equals 2 to the x, not x squared would be our usual polynomial. Y equals x squared. An exponential is the opposite of that, and it's y equals 2 to the x. So since we're going to be using these, what we really need to remember are all of our exponent rules. This is a printout that if you are in class, you can go ahead and grab if I have not passed them out already. So our exponent rules, the first one is that anything to a 0 power is 1. When you multiply two things that are the same bases, then you add the exponents. And when you divide two things that are the same bases, you subtract the two exponents. Then also, if we have an exponent to an exponent, that's when you multiply your exponents. They kind of have like a rule one removed from the actual rule. Like multiplying isn't just multiplying, it's adding. It's still the positive rule. You're still getting bigger, but it's a little bit different. If you have two things that are multiplied and you're raising them both to a power, then it is the same thing as raising them both individually. But be very careful here. This rule is not the same as a plus b to the x or a minus b to the x. Those are not the same. This is times, so you can distribute that power. In both of these cases, you would have to FOIL these out to accurately multiply all the terms that need to be multiplied. So be very, very careful here. If you have two things that are divided, you can raise those both to a power individually. So basically, if you have a fraction, you square the top, square the bottom kind of thing. And then the last rule that we use a lot, if we have a negative exponent, that just means it's in the denominator. So just keep those in mind. Oh, that's all that's on that page. Next page. So keep in mind, our natural number, we have a natural number and we have a natural logarithm. Our natural number is e. That works kind of like pi. It's just a symbol for a number that keeps repeating itself. That squiggly equal sign didn't work out, so what's it? That's a little better. 2.71828. I just copied that from a piece of paper. I don't actually know that. I just know it's 2 point something, which is all you really need to know. So use your calculator or just leave it. Anyways, our natural logarithm, remember, is a logarithm that has a base e. Or we shorten that just to ln of x. Since we write it so much, we just, calculus people are like, well, can we get a shortcut here? Everything else in our life is long. So they were granted a shortcut. So the connection between these two things, the connection between a natural number or our exponential function and our logarithm is whenever we have a log base e of a number is equal to x. What happens when we use our log rule that we've talked about briefly before, but that just means that our base to that number, so e to the x is equal to b. So this right here, e to the x, that is our exponential function. This is our log rule, by the way. We've called it that before. If you need some more help on that, let me know. I can help you out. But we have a natural exponential function and a natural logarithmic function. Our natural exponential function is y equals e to the x. our natural log function is y equals ln of x. Okay, so these two things right here, they are inverses of each other, and this is important to know. Inverses mean opposite. We talked a little bit about inverses. That was like our entire last section. So just like y equals x squared and y equals the square root of x, these are inverses. Like if we're solving a problem, we use one to undo the other. To undo a square root, you square. To undo a square, you do a square root. They undo each other. So the same way, our e to the x and ln of x also undo each other. If we have ln of e to the x, the answer to that is just x. Basically, I mean, this is kind of informal, but ln of e cancels out and you end up with x. Really what happens is your property that exponents on ln can move to the front. So we would have x times the ln of e. The ln of e is 1, so that's just x times 1, which is just x. So that's what happens there. We also have e to the ln of x. So it can work the other way around. So either e to the x being inside of an ln, or ln being inside of an e to the x. Again, those things cancel out. It's a little bit, the second one is a little bit more complicated than the first explanation, so I don't really go over it. If you're dying to know, ask me before or after class, and I'll let you know. But basically, the e and the ln cancel, and you end up with x. These undo each other. So we actually use those properties to solve equations. So let's look at some equations to solve and make sure that we can do these. So A, e to the ln of 2x equals 12. If we want to solve this problem, they already have that e ln of x relationship in there. Basically, the e and the ln cancel, and we have 2x equals 12. Solve for x, divide by 2. And that would be our answer. That one is a little bit easier. On this one over here, B, we have 4 times e to the x equals 83. Well, before we can introduce anything else, we need to get e to the x alone. So we're going to divide both sides by 4. So we're going to have e to the x equals 83 over 4. I'm just going to leave it. I'm not going to get a decimal. It's fine. Now, remember, what undoes an e, we need to get rid of this e because the x is up in the exponent. What undoes that is ln. So we're going to take the ln of both sides. So this would cancel and we get x. X is just the ln of 83 over 4. Which either you leave it like that, or you can plug it into your calculator and get a decimal if you're dying to do that. But generally, I just leave it right there. There's no reason, unless you're on a calculator portion of the exam and they're asking for the calculator, like the decimal answer, there's no reason to go further because that is considered an exact answer. So just leave it there. So let's look at 2 more just to make sure that we understand this process, and then you'll move on to your assignment. So we have the ln of 4x equals 1. So in this case, we need to get rid of the ln. So we do kind of a sneaky math thing, and we make both sides of this equation exponents of e. Because we can do anything to any equation as long as we do the same exact thing to both sides. So we put these things kind of in the exponent of an e. As long as it's the same thing on both sides, we can do it. So over here, our e and ln kind of cancel, do our funky cancel thing, and we have 4x equals e to the first, which we can just write as e is if we want. And then we divide by 4 on each side. So x is e divided by 4. Again, if you're dying to get a decimal, you can use your calculator, but generally I just stop there. I do have the decimal for this one. I don't have my calculator on me, so I can only go by what I wrote previously. 0.680 is what I got. And then our last example is ln of x squared equals 10. Now, there are a couple different ways to solve this problem. I'm going to give you the way that I think is the easiest. It's just the least amount of steps. So before we put the e's, do our little e trick like we did in C, I'm going to use an ln exponent rule, and I'm going to bring that 2 to the front. So I'm going to have 2 ln of x equals 10. And then I'm going to divide by 2. So I have ln of x equals 5. From there, I can do my little e trick. Now that ln is alone and it's just ln of x, so those kind of cancel, and x is e to the 5th. E to the 5th, just leave your answer like that. That is an acceptable number because e is technically a number and 5 is a number. So that's all numbers. That's like leaving 2 to the 5th, except for you know what 2 is and you can multiply that out without a calculator. E is this crazy decimal that we don't know without a calculator. If you're dying to get the answer and you got your calculator, you should get 148, always 3 decimal places, 413. Okay, you can round or truncate. If you have any questions, please let me know. But that's it for this intro, our kind of pre-calculus prerequisites before we start talking about our derivatives and integrals of our exponential functions. You have an assignment on Canvas that you need to complete.